Um, Good afternoon, all of you. In today's session of class 12 physics, we are going to continue with electric field. Now, okay, so electric lines of force is the topic for today. So, suppose there is a positive charge, uh, then if you place another positive charge in the vicinity of this charge, like suppose there is a given positive charge, okay, so there is a charge q, uh, there is some positive charge given, and in the vicinity of this charge, if you place another positive charge, then this charge will obviously repel that charge. So that repulsion will be directed away from that charge, and the direction of that repulsion, that is obviously the direction of the electric field, and if you plot it as lines, then they are called electric lines of field or electric lines of force. So from a given positive charge, any radially outward line is an electric line of force. So these are the electric lines of force for a positive charge, right? So this is an isolated positive point charge. Okay, now suppose if you have isolated negative point charge, so if you have isolated negative point charge, then these will be the electric lines of force. So any positive charge is kept over here, so it will be attracted towards this negative charge. So these will be the electric lines of force for isolated negative point charge. Okay, then we come to the third diagram. So this is the third diagram, identical positive point charges. So there are two identical positive point charges and these are the lines of force. Okay, now you have isolated positive and negative point charges. So there is a positive charge, there is a negative charge. Okay, there is a positive charge, there is a negative charge. And so they are actually, it won't be right to say isolated because there are two of them. So I'll just write identical. So there is an identical positive negative charge facing each other. So these will be the lines of force, right? So this is the diagram number 4, and of course the fourth one is that there is a single line of positive charge. Okay, there is a single line of positive charge like this. So for a single line of positive charge, this will be the lines of force. So for a single infinite line of positive charge, these will be the lines of force. So these are the different cases for lines of force. Isolated positive charge, isolated negative charge, identical positive point charges like this, identical positive and negative point charges, and finally infinite line of positive charge. So these are the different types of diagrams for lines of force. Now for these diagrams, we will have to make a list what are the properties of the lines of force. Like if you look at all of them, what are the common properties of the lines of force? So what are the properties of lines of force? Okay. Well, the first property as you can see that they will always start from a positive charge and they will always end at a negative charge. So the first property is that they will always start from positive and they will always end at negative. That is property number 1. Property number 2. Okay. Then property number 2, if you draw the tangent to the line of force at any point, okay, if you draw the tangent to the line of force at any point, then you will get the direction of the field at that point. So tangent drawn to line of force gives the direction of field. Now suppose if the field lines are parallel to each other, like this one, the field lines are parallel to each other, that means the field is uniform. If field lines are parallel, it means field is uniform. Okay, next we come to point number 3. Two lines of force cannot intersect, because if they intersected it would mean two different directions of field, which is impossible. So point number 3, two lines of force cannot intersect at all. By chance, if somebody says that what happens if they intersect, so if they intersect it would mean that there will be two directions of field at the same point. That is impossible. So this is property number 3. Okay, property number 4. Lines of force, they never pass through a conductor. Okay, property number 4, lines of force never pass through a conductor. That means inside a conductor the field will be zero, because they will not pass through a conductor. See, number 5, if the lines are very close, okay, if the lines are very close, that means the field is strong. But if the lines are far apart, that means the field is weak. Okay, if the lines are very close to each other, the field is strong. If the lines are far apart from each other, that means the field is very weak. This is point number 5. Point number 6, lines of force have a tendency to contract along length and expand laterally. You see the diagram which I had earlier drawn for positive and negative. You will notice that the diagram which I had drawn for positive and negative, So along the line joining them there is a restriction because they are kept at a certain fixed separation. So along the line joining them, the lines you will see that they tend to bulge out. If you go back to the diagram, you will see the lines bulge out. So along the length, the lines have a tendency to bulge out because there is a restriction. They are at a fixed distance apart. So you cannot have them closer or farther away than they actually are. So that is why they tend to bulge out. So expand laterally and contract along the length. This is point number 6. Okay, point number 6. The lines of force are smooth, continuous curves without breaks. Okay. So point number 6, the lines of force, they are actually smooth, continuous curves and there are no breaks. So there is no gap or discontinuity. They are smooth and continuous. So these are the 7 properties of lines of force. So this was the topic for today, lines of force. And now I'll give you the usual homework questions. Okay, the first homework question for today, there is a charge 0.2 coulomb, there is a charge 0.4 coulomb and the distance between them is 0.1 meter. Okay, there are two charges 0.2 coulomb and 0.4 coulomb and the distance between them is 0.1 meter. So at the midpoint of the line joining them, you have to find the field. Same question, second part. There is a point between them which is 0.05 meter from the right and 0.15 meter from the left. You have to find the field. So the same question has two parts. Find the field at the midpoint, find the field 0.05 from the right and 0.15 from the left. These are the two parts of question 1. Okay, homework question number 2. There is a charge 3 microcoulomb and there is another charge minus 3 microcoulomb, and they are 20 centimeter apart. So what is the field at the midpoint of them? That is the first part. Second part is what is the force if you keep a charge of 1.5 10 to the power minus 9 coulomb over here, then what is the force? So the first part is what is the field at the midpoint. Second part is what is the force if you keep a charge of 1.5 10 to the power minus 9 coulomb over there. Okay, question number 3. Okay, question number 3. There are two charges 6 into 10 to the power minus 9 coulomb, 4 into 10 to the power minus 9 coulomb. So they are 30 centimeter apart. So first question is that there is a point 20 from the left and 10 from the right. What is the field? Same question, second part, what is the force they both are exerting on each other? That is the second part. Okay, question number 4. There are two charges, one is Q and one is 4Q, and the distance between them is 6a. So you have to find the place where the field due to these two is 0. You have to find that place. So where is the field due to these two? 0. That is the question. This is number 4. Okay, question, the fifth and last question of the homework. There is an equilateral triangle of 10 centimeters each, and at the vertex A there is a charge of 0.1 microcoulomb. So at the midpoint of BC, what will be the field? Okay, each side is 10. So at A, 0.1 microcoulomb is kept. So at D, what will be the field? So these are the 5 homework questions. There will not be any sessions tomorrow because tomorrow is Sunday, and we will have next sessions on Monday. So you have to submit the homework by 9 p.m. on Monday. That will be all for today's session. Bye all of you.